Okay, let's proceed on to measuring the x components. Now, just to review, the very first data set I did, A, B, that was for the initial momentum. Then, in the last video, we first measured the initial momentum distance, the 1.5. Then what we did is we measured the y's for both balls, the D and C, after the collision. So in this video, we're going to measure the x's for the balls after the collision. So you're going to get two sets of data for each of the balls, the x's and the y's. Now initially, we did the x's, the y is 0 for the initial momentum, because when the ball launches off, that's going to be the x direction. It's for the x-axis and it has no y component. Then when it collides, it has both a y and an x, as does the other ball. So I'm going to write the x's in a different colored pen, but we use the same balls. So what I've done is my point A is right underneath the thing, and I put this meter stick right here, and I'm measuring from the meter stick, as I'm going to do the same way on the other ball. So let's just read off the values. So number 1, it's 30 centimeters, let's see, 30.3. So 0.303 meters. So the blue is the x components. The x's are the black ones that we did before, and this is ball D. I don't know why I'm doing D before C, I just happen to be over here. So ball number 2 is, let's get rid of parallax error here, 28.2, so it's 0.283 meters. So again, that's an x value. 3 is 26.3. I mean, it's probably 26.1. All right, 0.261 meters. And the 4 is 0.25. Actually, that's actually the number 3. Let me take that back. That is probably it's a little less than 2.26, isn't it? Maybe it's 0.259. I think what I did is I went the wrong direction on that one. I think that's 0.259. And this one, 0.254. So this is a 2. This is a 9. And the last one is, that's far away. I'm just going to move this up so we can see it better. 0.231. Okay, so those are our x values. You've got 0.303, 0.283, 0.259, 0.254, and 0.231 for ball D. So what I'm going to do is read off the x values for ball C now. So we're going to come over here. This is going to be a little more than a meter, so instead of using a meter stick, I have to use the second one of these things. So again, I'm going to use the blue pen. The values you see now are the ones we did in the last video. Those are the y values. What I'm going to do is now measure the x values. Now the C's and the D's, this is about like the other ones were around 0.25, around 25 centimeters. These you can see are above 1 meter. They're about 1.2. So if you add 25 to 20, you get about 1.45-ish. And sure enough, that's actually what the x value is for our initial momentum. So if you add those two, the cx and the dx together, you should get the initial momentum in the x direction. So let's just read them off, and then we'll do the calculations a little later. So make sure this is straight. There's I don't have a straight edge right here, so I'm trying to do the best I can with this. So it's 1 meter. So we're past 1 meter. This is 1 meter here, 1.1. So it's a little over 1.5. 1.1, 1.154 meters. Number 2, that's about 1.1, let's see, 82 meters. Let's go move this down a little bit. This one's almost 1.2 meters. Actually, there's 2 of them together. They got stuck really closely. The number 3 and 4. So one looks like it's 1.196, and the other one is 1.196 meters, and the one next to it is 1.198. You got to be careful because it's still 1.1. It's less than 1.2, so don't put 1.9. It's a common mistake people make when reading off these things. So then I have 1.208 meters. This is not quite 1.21. Okay, so again, those are the x values. 1.154, 1.182, 1.196, 1.208, and 1.198. So now what you're going to do, now that you have all those values, you average them out, and you can fill in your data sheet and find the percent errors. Your instructor will guide you through it. It's just simple multiplication and adding and things like that.